Welcome to Session 8 of Data Analysis using Python. I am Bonasika Galama, your facilitator from the land of 1,000 hills. Session 8, Detection and Treatment of Outliers. What is an outlier? This is a data point that lies far away from the majority of the data in a dataset. For instance, the blue marbles here represent the data points that are close to each other. The green marble represents the data point which is far away from the majority of the data. This is an outlier. In other words, an outlier or outliers are the data points or values that are out of the range of the majority of data. What is the impact of outliers? Outliers can pull the mean toward them, making the mean unrepresentative of the majority of the data. You, as a data analyst or a data scientist, if you compute the mean, variance, standard deviation, or any other statistics such as sampling errors, an outlier inclusive, you are likely to mislead decision makers and program implementers. So, you should make sure that you detect the outliers and clean them so that the computed statistics are accurate and reliable for decision making. For instance, here is the distribution of weights of 20 persons, where 3 persons have got extremely high weights compared to the majority of weights that lie between 57 and 69. The mean here is 70.8, which is out of the range of the majority of weights, as you can see here. This is a biased mean pulled by these 3 outliers. At this condition, where the outliers are extremely high, the longest tail of the curve falls to the right. This is positively skewed data. The outliers here are contrary to the preceding outliers. These are extremely low outliers. The mean is 65.5, which is out of the range of the majority of weights that lie between 66 and 75. This is a biased mean pulled by these extremely low outliers. At this condition, where the outliers are extremely low, the longest tail of the curve falls to the left. This is negative skewness, negatively skewed data. Here, at this distribution, there is a very slight difference between mean and median. The mean and median, this means that the mean and median are equal. So the condition where the mean median, and mode are equal, the distribution of the data is normal. This is represented by the normal distribution curve. Also, at this point, the standard deviation is optimized to the minimum possible value vis-a-vis the standard deviations where the data are skewed. Here, it means that the data, our data, are not sick. They are healthy, accurate for decision making. Now, let us take a short break and we will dive back into a practical analysis using the real-life data. In the meantime, I would love for you to subscribe, like, and comment. Your participation helps me to know that we are all on the same page and engaged with the content. Thank you. This is the command window. We can also write the text or comments here. For newcomers who are not aware of how we got at this interface, just visit my previous sessions. They explain very well the few steps of how to get here. This is untitled. We can rename it as the session 8 underscore bonus. Name. The work that we are going to do is titled Detection and Treatment of Outliers. Then we need to import the libraries that are relevant to our task that we are going to perform. Import pandas as PD, import Seaborn as SNS. Seaborn library is for visualizing the outliers. Run. Then we are going to import your data frame. Then import your data frame. Let us call it df equal bring your pandas library dot read underscore excel within inverted commas import the location of the data frame. Come here to folder. The folder is named session 8, saved in the document in the desktop, session 8. Open it, and then within the folder there is my data frame. It is called dataset. Right click, go to properties. This is my location. Copy the location and paste it here. Then go back and copy the data frame. This is my data frame. Copy it. .xlsx double backslashes. Run. And then execute. Let us limit our data frame to only one row. In order to remain with the original data frame, of which we don't want to change during our task, Let us create our new data frame. EFF equal regional data frame dot copy. Then execute the new data frame. This is our new data frame. Our variable of interest here is age. We are going to find if age has got outliers. This is our age, B1, A3Y. Let us create the new variable for this. DFF age equal DFF on new dataset or data frame, the variable B1 A3Y. Run and then execute .head. The new variable created for age is age. Yeah. We're going to use this variable, the new created variable. Let us examine if our age is float. Bring our data frame and age, the new created variable. Run. Remember, running you can either select here and click here, or you select here and then shift enter. Our quantitative variable age is integer type. It is a non-float variable. Note here, before performing any statistical operations, you should first of all convert the quantitative variables of your interest to float. Converting quantitative variables to float type enhances compatibility and accuracy in data handling. This conversion is crucial for performing statistical analysis, building machine learning models, and executing mathematical operations. So let us change our variable age as integer type to float type. Bring the new dataset and the age equal, bring the dataset again and the age dot as type float. Run. Let us test it again. Run. You can see it is changed to float type. This is good. Let us run the statistics. Describe. Run. The mean is 22.97. Standard deviation is 18.6. Let us also find the median. Median. Run. The median is 18. Let us keep our computed median here as the text. And age is 18. We also find the mod. Use the sum command and replace median by mod. Run. The mod is 7. Let us also keep our computed mod here as the text. Mod age is 7. We omit this command. Okay. Now, the mean is 22.9. median is 18, and the mode is 7. So there is a big difference. What is this kind of summary statistics is going to help us? We are going to keep on seeing how mean and standard deviation are changing as we clean the variable. We are now going to detect the outliers. Detecting or visualizing outliers. Using box plot. Bring your library Seaborn as SNS dot box plot. Bring your new data frame and then your variable of interest H. Bring again your Matplotlib library as PLT. But title of my box plot. It is edge distribution. Remember, we imported the library Seaborn, which is SNS, but we did not import the library Matplotlib, which is PLT. Import again matplotlib.pyplot as PLT. Run. And then let us run our box plot. You can see how it looks like. These are outliers. It has got a lot of outliers. Using graph, let us copy the same command, paste it here. Using normal distribution curve, SNS dot, let's say dist plot instead of box plot. You can see our edge distribution is skewed to the right, meaning that our edge as a variable is infected by outliers. This is how to detect the outliers or visualizing the outliers. Now, I am going to clean this infected variable, H. There are different methods used to treat the outliers. There is a percentile method, interquartile range method, square root based method, log transformation method, and so on. The first thing you do here is to calculate the median. Median edge equal, bring your data frame and your variable of interest dot median. The second step is calculating percentiles. Our bound equal, bring your data frame and the variable edge dot quantile 0.05. Upper bound equal, bring your data frame and your edge 0.95. Lower bound Values below 5% are outliers, above 95% are outliers. Step number 3 is replacing the outliers with the median. Now, being your data frame and your variable age equal, being your data frame again and your variable age, dot apply, open the bracket, lambda x, replace the median age if x is less than lower bound or x is greater than upper bound, else x. This line applies a lambda function to each edge value. If the edge is less than lower bound or greater than upper bound, the lambda function replaces it with the median. Otherwise, it keeps the original edge. Run. Let us visualize again if there are still outliers. Let us bring again this command and see from here. Run. You can see no longer outliers. Variable is now cleaned. For normal distribution curve, run. Now you can see how it looks like. Edge distribution, normally distributed. Compared to here. Here it was positively skewed. Can you see? Let us learn again the statistics of mean, median, mode, and standard deviation. The data frame, edge, dot describe, run. The mean is 20.9 and the standard deviation is 14.6. What about median? Copy the same command here. Median. Run. The median is 18. And mode, this is mode. Run. Mode also is 18. The mean is 20.9, median edge is 18, and mode is 18. There is a slight difference between mean, median, and mode. Before being cleaned, there was a significant difference between mean, median, and mode. The standard deviation was high. After being cleaned, there is a slight difference between mean, median, and mode. These three statistics are approximately equal. And also the standard deviation reduced to 14.6, meaning that the less the standard deviation, the higher the accuracy of data. Therefore, this mean is reliable compared to the preceding mean before being cleaned. Let's take a short break for now. We will pick up where we left off and finish our lesson soon. I would greatly appreciate it if you could subscribe. It helps me ensure we are all on track. The cleaned variable age can be used in both disaggregated and aggregated forms, based on your analytical needs. It can also be used in combination with the other variables for further statistics. The main objective of this lesson was helping you gain a deeper perspective of what are outliers and how to handle them using one of the methods. Other methods include interquartile range, log transformation, trimming methods, etc. As you can now have a broader understanding gained from this lesson, you will figure out how to use the rest of the stated methods. Thank you for paying attention. Remember to subscribe, like, and comment. We'll meet for the next session.